We're moving away from limits today and devoting the entire lesson to differentiation. I would make sure you have a pencil and a piece of paper and a calculator today. We will be using our calculators at the very end of today's lesson. But as you remember from yesterday, differentiation, or finding the derivative, is really all about finding the slope at one point. And yesterday we found the slope at one point using that limit definition of the derivative. Thankfully, though, we don't have to do that every time. Our main rules for differentiation are product rule, quotient rule, and chain rule. We are not going to go over those today because we have been working with them for 4 months now. So hopefully you know product rule, quotient rule, and chain rule like the back of your hand. If you need extra practice, you can find tons of examples in your textbook or in your notes. And as we do today's lesson, we'll be practicing them in the context of other problems. Probably the most basic way that we use the derivative is in writing a tangent line. This is that point slope form that we've done probably hundreds of times by this point. And what you need to write a tangent line is a slope and a point. I hope that if you've learned nothing in this class, you remember that a tangent line, oh wait, my smartboard is not plugged in. There we go. I hope you remember, of all things in this class, that to write a tangent line, you need a slope and a point. Here we're going to do the line tangent to f of x equals 1 over x at x equals 2. We need a slope and a point. The easiest thing to get is our point, because we're already given half of it. We're given the point x equals 2, and all we need to do to find our y value of that point is plug it into our function. So we have the point f of 2 equals 1/2, or the point 2 comma 1/2. We don't have a slope function yet. We just have our original function, but what we're looking for is the slope at any point on that function. And as you remember from yesterday, we talked about finding slope at a point is the same thing as differentiating. So what we need to do is find not our original function, but our derivative function. The derivative of 1 over x is negative 1 over x squared, which you should have memorized, but you can also find out using power rule. And then we can plug in our x value of 2 to get a slope of negative 1/4. Point slope form, y minus y1 equals m times x minus x1. We have a point and a slope, and we can just plug it in. So my y1 is 1/2, slope is negative 1/4, and x value is 2. And I am super okay with you leaving your answer looking just like that. On a multiple choice question, they might have simplified that, distributed the slope, and added that y1 value over. But I trust that you can do that.